Good morning to one and all present. I welcome you for a second day of FDTP on data structures. So we have Subhashree ma'am as our chief guest for today's first session. So she has 8 years of teaching experience and 3 years of industrial experience and has published more than 20 papers in national and international conferences and journals. And her areas of interest are machine learning, data structures, database management system, operating system, computer networks, and neural networks. I welcome you, ma'am.
Thank you, Aarti ma'am.
So the session is all yours, ma'am. You can start your session.
Good morning to all the faculties present here. Today we are going to see about stack data structure. Hope I'm audible to you. Am I audible, ma'am?
Yes, ma'am, you are audible.
Yeah, thank you. Stack is a linear data structure and it can be implemented using array as well as using a linked list. So today we are going to see how a stack can be implemented using an array. So since it is a list here, it has a restriction that insertion and deletion can take place only at one end of the list. So when you take a list, an array, if you speak, it has two ends, right? Front and rear, or the first and the last position. So here, insertion and deletion can take place at only one end of the list. So we name it as a top. Only at the top index you can insert an element, and the same, the top index only you can remove an element. So it follows the order last in first out or first in last out. There are various applications of stack which includes uh, arranging the cafeteria trays one over the other. Various, if you arrange A, B, C plates, you can take up C, B, and then A in the order. So stack of pennies or the coins that you arrange on a table, and rack of boxes or folding addresses and keeping it in the drawer or a shelf. These are all the various applications of stack. And there are various real-time applications of stack, which includes undo redo operations in a word processor. Control Z, control H. These are various applications. Just a minute. And then the forward, backward button in the surfing window of a browser, history of various websites. So whenever you surf a website, it will be ordered in a stack data structure, and message logs, whenever formal messages in the messenger or a call logs, that will be arranged in stack order. And then emails, Google photographs, photos in the gallery, YouTube downloads, the various notifications which appears. The latest one will appear in the top of the window wherever you're working with. And when we speak funnily, we can say that wearing bangles, wearing shoes, so and all, a stack data structure. And media playlist. Usually we used to hear songs, right? So it will be listed in a queue or a stack data structure. previous and next songs, it will be arranged in as per the stack format, that is last in first or first in last or format. And we have various operations of stack, which includes push, that is the insertion. Normally, when it comes to an array, we perform two basic operations. One is insertion, another one is deletion, and the third one is a display. Normally, we have to display what are the contents in the array. First thing is push. As the name indicates, it's the insertion of an element into the stack, and another one is a pop, and it's deletion from the stack. That is, we can remove an element which is pointed by the top pointer. And the peak, we can display the top element which is available in the stack. And then isEmpty isFull function will represent that whether the stack is empty or whether the stack is full. If the stack is full, you cannot insert an element into the stack. And if the stack is empty, you cannot delete an element from the stack. And normal display operations. We can see about it in detail. Let me show you with that example. As I said, stack is the linear data structure. So linear data structure, and it stores homogeneous content elements, that is elements with the same data type will be stored in an array, and it follows LIFO or philo order, which is last in first or first in last of order. Last in first in last of order. And then when it comes to the operations, you have to insert an element into the stack. So consider a stack of size. Consider a stack of size 4. So the array index starts from 0 to 3. So it ranges from it is an array implementation, right? The index ranges from 0 to n minus 1. N minus 1. Here n is 4, so it ranges from 0 to 3. Consider this as an array 0, 1, 2, and then 3. So this is the index 0, and this is the index 1, and this is the index 2, and this is the index 3, where you can store maximum of 4 elements. So here size is equal to size or n, whatever it is. You can mention it as n equal to 4. It ranges from 0 to n minus 2, 0 to 3. Now, if you want to perform set of operations, say, these are the list of operations that I have to perform. For example, pop is nothing but deletion, right? So it doesn't take any kind of parameters because we cannot mention the element to be deleted from the stack because the top element only can be deleted from the stack. So it doesn't take any kind of parameters. And when you want to insert an element into the stack, you have to pass an input, say 34. Now, 45. These are a sequence of operations that we're going to perform. Here and there we can make use of this display function to display the stack content and so on. If you want to perform this pop, initially the stack content will be empty. This is your stack of size 4. So I have a stack of size 4. It is an array of type integer. So it doesn't have any content and I can insert an element only at one end of the list. So I'm naming it as top. To represent the stack as empty, I'm initialing the top to -1. And now top is -1. Top is not pointing to any of the indexes in the array. Now I'm going to perform the very first operation is pop, which means deletion. A stack is empty. You cannot delete an element from an empty stack because it doesn't contain any element. So you have to check. The precondition is if the top is -1, then you are not supposed to delete any kind of element from the given stack. So you have to print as stack is empty. Or underflow. You have to print it either stack is empty or underflow because you cannot delete any element from the given stack because it doesn't contain any elements. And
Respected professors, kindly wait for the guest to join. She had some network disconnection. She'll be joining soon.
Initially, we performed pop operation. Stack is empty, so I have displayed it as stack is empty or underflow by checking the condition whether the top is -1. And then we performed push operation, that is 34. So I have to increment this top pointer by 1, and then top is pointing to 0, and then the value 34 is placed into the stack. And then now I have to perform push of 45. So again, the same process. I have to check whether the top is pointing to n-1. If the stack is full, I cannot perform any kind of push operation. If not, the insertion will take place. So now top will be pointing to index 1, incrementing top by 1, and then I have to place this value 45 into the stack. And then performing the next operation, push of 55. The same sequence will be followed up. Top will be incremented by 1, and then the value 55 will be placed at the index 2. In the next process. Push of 67. Again, the top pointer will be checked whether it is equal to size -1 or not. If it is equal to size -1, that is n-1, stack is full. If not, I can perform that insertion operation. So incrementing this top by 1, it is pointing to index 3, and then value 67 is inserted into the stack. Now, taking with push of 78. 78 will be passed. Now the stack contents tab top will be pointing to the index 3, and n-1 is also 3. Now the stack is full, so I have to display stack is full or overflow for this push of 78. And then this top -1 check is for pop operation, and if the top is equal to n-1 is for push operation. That is, you cannot delete an element from an empty stack, and you cannot push an element into the full stack. This is the two major things that you have to check. And then for the 78, you have to display it stack is full or overflow. And then we can perform any kind of operations like pop or display. So when you arrange a list of books on a table, you're not going to draw a random book at any point. So you'll be taking from the top and then to the bottom. So if you have to display this stack content, then you can display only from this top to 0. So if you want to display a content of the stack, say. So it will be displayed from this 3 index to 0 index. The content will be 67, 55, 45, and then 34. These are the order in which the stack elements will be displayed. So like this, when you have to write a code for pop operation, pop we have to delete an element now. Say I have to call pop sequence of pops and call and then pop. And trying to pop an element from the stack. Since the stack is full, it contains 4 elements, so I can continue with this operation. So I have to check pop-up function. I'm not specifying any kind of parameter over here because you cannot specify any elements to be deleted at random over the stack, because the only element which is pointed by the top can be deleted out. And I have to check if the stack is empty. If this top is pointing to -1, then I cannot delete any kind of element. And then I'm making a printf statement stating that stack is empty or underflow. If not, then I can take up an element and I can return. You can write it in two ways. That is either by returning a value or by using your normal printf statement. If you want to take up an element, this is the item that is to be popped out. And then I have to take it up from the stack. 67 can be deleted out from the stack. So the stack of top. Now the elements to be deleted is placed at item, and I can increment by top pointer by 1. This statement can be written in a single line, that is post decrement. Stack of top, stack of 3 will be 67. 67 item will be placed into the 67 value will be placed into the variable item, and then decrementing the top pointer. Now top will be pointing to 2. Now I can return my. So this is one way. Or else, if you write it as a void function, then you can print over here. This is not required. You're not supposed to return any kind of value. And then you can just make a print statement. You can print this stack of top, and then you can decrement this top pointer. Or you can write the same as I mentioned earlier. You can mention both in the same statement. Stating this. So it will be printing stack of top, and then top will be incremented by -1. So normal printf statement, you can be printf %d. That's the model of the comma stack of top, and then decrementing the top pointer by 1. And then closing this function. This is your pop operation. So first when pop is performed, it is check whether the top is pointing to -1. No, it is pointing to 3, and hence I'm printing this stack of top 67 value, and then I'm decrementing this top pointer by -1. Now again I'm performing this pop operation. I'm trying to delete an element that is 55. So it is checking for whether the stack is empty, not. So again, I'm decrementing this top pointer, printing value 55, and then decrementing this top pointer to 1. And again, if I perform this pop, 45 will be printer, and then the top will be decremented by 1. And we'll point into the index 0. Now if I perform this fourth pop operation, top will be pointing to 0. Still I can perform this deletion. So now top will be pointing to -1. Top will be pointing to -1, and then the stack will be empty. Now if I perform this pop operation, top is pointing to -1, and I have to display this stack is empty or underflow for this pop operation. So further popping is not possible. So this is your stack insertion, and this is your stack deletion operation, and then display function. When it comes to display, as I said, you cannot display an element from an empty stack. From a full stack, you can display. From an empty stack, two different cases: an empty stack and a full stack. These are the two things. So when it comes to pop operation, you're checking whether the stack is empty. When it comes to push operation, you're checking whether the stack is full. Likewise, when you have to insert, when you have to display, when you're trying to display an element, then you have to check if the stack is empty. If the stack is empty, then I cannot display an element from an empty stack. So the primary thing is the function is not going to return any kind of value. I'm just checking if the top is -1. If the top is -1, the stack doesn't contain any data. So I'm just printing stack is empty. No data to display or no data to display. Likewise, whatever you wanted to display, you can have it. Not if it contains data, even a single data, then I can make a print of statement. Yes, it should be a looping construct because we are not aware of how many elements we present in the stack. As a human, we know, but I will not know it now. So we need an iteration variable starting from a particular variable. Now, as I said previously, top is pointing to 67 over here. So I mean the index 3 and the value of 67 over here. I have to display the contents from top to 0. So I'm just starting with top and then decrementing sequence. So 3 will always be greater than 0, 2 will always be greater than 0, and so on. So that I will be greater than or equal to 0 because till the index 0, I have to proceed decrementing sequence by 1. Now I have to make a printf statement. What you have to print is stack of. Usually used to the stack of top here. I have hand over the stock variable to the index I to the variable I. So we're taken care by index I. That's it. So first initially you have to check whether the stack is empty. If it is empty, then you have to tell that no data to display. If not, I can start from top till 0, decrementing by sequence 1, and I can make a printf statement and I can count out. That's it. Assuming is top is pointing to the index 67, say. So in that hand, I'm not going to change the stop pointer. So kindly make a note of this. I'm not going to change the stop pointer. I'm just assigning this index to the variable I and then I'm iterating. So I'm iterating this through a variable I. You can use any variables that you wanted to use. So right from top, I'm just displaying it is greater than 0. So stack of 3 will be 67. Stack of 3 will be 67. And then decrementing sequence. Now I'll be pointing to index 2. So stack of 2 is 55. Now decrementing by 1. I will be pointing to index 1. So stack of 1 is 45. Decrementing I by 1. So this I will be pointing to the index 0. Stack of 0 is 34. Decrementing it by 1. Top will be I will be pointing to -1, which is not greater than or equal to 0, and hence the condition fails. It will be quitting out of the for loop, and then the display function gets execution gets failed. So this is your display function. The three different things, important things: push, pop, and then display. The two more things is you can check whether the stack is empty or full, and the third one is you can display a stack top element, normal thing. So if you want to display a top element, as I say, it's very simple. You can display just this stack of top. So if you want to display a peak element. So it's enough if you print stack of top. Top element. So your precondition will be, what will be your precondition over here? Is there any precondition to be checked over here? If you want to display a top element, that is an element which is pointed by the top pointer in the stack array, you have to display it using the statement stack of top. If the stack is empty, you cannot insert an element. So you have to check is empty. If the stack is empty, then I cannot display the stack element. So this condition you have to check. And then one more condition you have is full. How do you check is empty and how do you check is full? So orally it can be said as this statement. There are two different things: is empty and is full, right? Stack is empty or not? The stack is full or not? So already I have written this code. So I can use. How do you check if the stack is full? How do you check the stack is full? Here you have the top is minus n minus 1. The top is pointing to size minus 1. That you say that the stack is full. So in that case, if you write this function to be of int type, the function is going to return integer type value, then you can place here return 1. The stack top pointer is pointing to n minus 1, that is size minus 1, you can return 1. If not, you can return 0. On the other hand, how do you check if the stack is empty? The top is pointing to minus 1, yes, so we can return 1, and then if not, you can return 0. So let me show you the code. Hope the presentation is visible to you. So far, we have seen that the things I have explained to you so far. It follows the order asking first or requesting last word order in the pile of plates, undo redo operation in various histories of the browser and normal messages, the call logs that you have on your phone. It follows last in first or first in last word order. And these are the various operations that we have discussed so far. Push, which is insertion, pop, which is deletion, and the peak or the top element that you have to display. There's a single element that the top pointer points to in the stack. Is empty is to check whether the stack is empty, and the is full function is to check whether the stack is full. The display function to display the content of the stack as and when required. A normal push operation, that is, it needs an element to be inserted into the stack, and it has this. The precondition is the stack should not be full. As I said, it should not point to n minus 1, that is size minus 1. And the post condition is once you insert an element into the stack, it has to be at the top of the stack. That's it. That is, that element should be pointed out by the top pointer. And push operation. So when the top is pointing to size minus 1, as I said, it is n minus 1, you can say stack overflow. If not, you can increment the top pointer by 1, and you can make the x2 point to stack of top. Next is pop. Insertion over, and then pop is deletion. So you cannot mention any parameter over here. Only the element which is pointed by the top pointer can only be deleted from the stack. So here the precondition is the stack should not be empty, and the post condition is once you delete an element, the top pointer has to be decremented by a sequence of 1, and the element has to be removed from the stack. Or you can display display the element in the stack as a printf statement, or you can return an element by having a return type. So it depends, it's left up to the user. And the top is pointing to -1, indicating the stack is empty. So you can mention it as stack underflow. And you can take up this top element into the item variable, and you can decrement this top by 1 sequence, and you can return that element. So the next one is, this is a simple illustration over here. Now the top is pointing to -1, stack is empty. And then if you want to push an element 2 into the stack, the top is incremented by 1, and then out initially in the first step, top is pointing to -1, and now I'm incrementing this top pointer by 1, and it is pointing to the index 0. Now I have to push an element 2 into the stack. So now the element 2 is inserted into the index 0, which is pointed by the stack, I mean the top. The second operation is push of 3. Now again the same process, top index is incremented. Top value initially in the previous case it is 0. Now it is incremented by 1, and it is pointing to the index 1, and the value 3 is pushed onto the stack. And then again push of 5. Early top was pointing to index 1, and then increasing again it is incremented by the sequence of 1. It is pointing to the index 2, and then we have inserted the value 5 into the top stack of 2. Next, pop. So you're not passing any kind of parameter, you have to decrement it. So stating that you can decrement, you can delete only the element 5 from the stack. So top index is decremented by the sequence of 1. Now 5 is deleted from the stack. And then again, if you call the pop function, top is decremented by 1. Since it is not equal to -1, we can decrement it. So now element 3 will be removed from the stack. Now again, if you insert an element into the stack, top will be incremented by 1 sequence, and the 10 will be inserted into the stack, replacing this 3 by 10. So you can access only index 0 and 1. Even if 5 content is present into the stack, the top is pointing to 1. So you can access only from 0 to 1. That is from 1 to 0 only you can access. The next is a peak or top element to be retrieved. Peak element or top element to be displayed. So stack of top, the top is pointing to -1. We cannot take over any element from the stack. So just a printf statement. Next, stack overflow and stack underflow condition checking. So how do you check whether the stack is full or the stack is empty? Right from the beginning, the same thing. The top is pointing to the size -1. It is the stack is full. We cannot insert any value into the stack. So stating that return -1, and then if not return 0. So next is you have to check whether the stack is empty. So underflow, you have to tell that if the stack is empty, then you can mention it by top pointing to -1. If it is pointing to -1, they can return 1. If not, return 0. The same thing you can use it. So there are various, these are the things so far we have discussed. So stack ADT, so I am repeating the same thing. Stack is an abstract data type, and it is a linear data structure. Stores the homogeneous group of elements, and it follows the order LIFO or FIFO, that is last in first or acoustic last or. It has a restriction that insertion and deletion can take place at only one end of the list, which is named by a variable top. You can name it as a pointer. Various applications we have discussed. Naming like undo redo button, that is an operation which is used in the word processor, or the syntaxes in the languages that are passed using stacks, and forward and backward serving in the browser. History of visited websites so far in our history, in our Chrome browser, any of the browsers. Message logs and all the messages that that we get are arranged into the stack. Normal our call logs, emails, the photos in the gallery, whatever the YouTube videos that we watch, or the downloads that we have, the notifications that always the latest one that appears first. And when we speak funnily, we can say that wearing bangles or the shoes, or arranging a pile of plates on the table or arranging chairs one after the other after the function or during the function. These are all the various examples of stack. So recursion, recursive code, as the name indicates, recursive code. So recursion is also an application of the stack. And normally we used to hear songs, the playlist. We have a media playlist. So here the stack as well as a queue is followed. When you queue, when you shortlist out, it will be arranged in a queue, and the previous and the next button acts as a stack. So the media playlist contains both the data structure, stack, and then queue. The previous and the next strong button will be the application of the stack over here. And various applications we have discussed, I mean operations we have discussed. There is a push pop, and the top element to be displayed is empty, is full, and then display function. So as and when required, when you want to check the content of the stack, you can make use of this display function. Various operations we have seen. If you have any queries, please you can faculties. If you have any queries over here, please, most welcome. Before you get into the applications of stack, please make sure that you are aware of what a stack data structure is and what are the list of operations you have to perform over. So hope you don't have any queries. So let me start with various applications of stack. So normal function call, a normal recursive code that you write now that uses stack memory and then the stack data structure, the expression evaluation. Normally you have a mathematical expression that has to be evaluated. So it has to be converted into infix to postfix or prefix, and then it will be evaluated. Normal in a calculator, the infix expression, whatever you give, it will be converted into the postfix expression and it will be evaluated, right? So, and then passing of the string and so on. So coming with starting with the function call. Let me explain you with an example. Sorry for the inconvenience, ma'am. The link will be posted shortly. This is session one link only. It will be posted shortly. Yeah. So hope you are clear with this operations. Stack with the size and making implementing it as an array and then the sequence of operations to be performed. Alternatively, you can perform any kind of push or pop operations and then display sequentially by checking your is empty, is full, and then displaying the peak element and so on. So now function call. One of the applications, a function call. Stack. So one of the application is here is function call. So how does this happen? Function call, normal function call. So here is a sample function where you, where we can explain this function call that uses a standard data structure. Normal factorial function. Let me explain you how it works. Factorial. How do you implement n factorial? 5 factorial, the 3 factorial is 3 into 2 into 1. So how it makes use of status. Minus 0 dot n is pointing to 1 is 1, then you can return. Simply I can return 1, right? Not. I can return, else I can return n into factorial of n minus 1. This is here 4 for finding the factorial of a given number. Else is optional. Make a very clear statement and it's using this else, but still it is optional.
Subha ma'am, sorry for the interruption.
Hi,
So,
ma'am.
I just have a photo session.
Yeah, okay. Yeah.
Respected professors, kindly switch on your video for a photo session.
Yes, sure, ma'am. Sure.
Ma'am, you too just switch on your.
Do you want me to stop my presentation, ma'am?
No, no problem, ma'am.
Okay, thank you.
You can switch on your camera too.
Okay, ma'am. Okay.
I request participants to kindly switch on your cameras for photo session. Professors, kindly switch on your camera for video session. I request the participants to kindly switch on your camera for video session. Professors, kind reminder, kindly switch on your camera for taking photo. So these photos are to be submitted to Anna University for verification and proof. So I request you to kindly switch on your camera. Professors, just try to switch on your camera. Thank you, professors. Thank you, Shubha ma'am. You can continue, ma'am.
Okay, ma'am. So let me continue with the session. Photo session is over. So thank you. Now, in the main function, if I call upon this factorial of 3, how does it get computed? 3 factorials. 2 1. So likewise, it gets computed and the value will be 6. Now, I call factorial of 3. You have a stack to store the content. So consider this as stack memory. Where we have to store the data. The holder functions will get stored in the stack memory. So when you call upon factorial of 3 in the main function, so this factorial of 3 gets placed into the stack, and then 3 that is checked with n. The 3 is the value that is passed as an n parameter, which is not equal to 0 or 1, and hence I'm holding n into, that is 3 into this factorial of n minus 1. Factorial n minus 1 is 2. Okay, here. The function call of factorial of 3, 3 into factorial of 2 will be called. So again here, factorial of 2 will be placed, and then for which the condition will be checked as whether the 2 is equal to 0 or 1. No. So 2 into this factorial of n minus 1, that is 1 will be placed here in the stack again. Factorial of 1. This the return statement will be n is equal to 1. So here this return 1 will be executed, and hence this function will return 1, and the called function will be here, right? So here value 1 will be replaced, and this will be popped out of the stack. Now once this value return 1 is returned by the function 1, then it will be placed over here where in the factorial of 2 is into the stack, and then 2 into 1 will be computed as 3, value 3, and this 3 value will be stored in the previous call, and this function will be popped out of the stack once this value 2 runs 2, and once this value 2 is returned to the previous call, this will be stacked up out of the stack, and hence the next will be computing of 3 into 2, is 6. Once the value is computed, this factorial of 3 will be popped out of the stack, and this 6 value will return into the main function where the original call is being made. So this is your basic function call where a stack data structure is to be used. Hope I'm clear to you. So again, repeating, one of the applications along with the inputs to postbits expression conversion or expression evaluation, and then with the function call or balancing symbols. The basic thing what we use in a day-to-day life, that is a normal recursive call that uses a stack data structure, that is a stack memory it uses. How does it uses is explained with an example of factorial of a given number, 3 factorial. So how does it gets computed? Whenever n value is 0 factorial is 1 and 1 factorial is 1. That is a very basic condition that you have to write. And if it is more than 1, if it is greater than 1, then you have to place that larger value and you have to pass the rest of the n minus 1 value for the next function call. So once the next function call has been called, it will be put on into the stack memory until it cannot be further proceeded. So 3, 2, 1. Here, further proceeding is not possible, and hence it returns a value 1, and the returned value is stored into the where the function it has been called previously. And hence, once it returns a value, it is popped out of the stack. And the same thing, after the computation is over, this factorial of 2 is called by factorial of 3, and hence this factorial of 2. Once it returns the value 2, it is popped out of the stack. And again, 3 into 6, once it is calculated, this factorial of 3 is popped out of the stack, and the 6 value is returned to the main function where the original call has been made. Hope I'm clear to you. If you have any queries, please do ask. So today we have seen what a stack abstract data is, and what are the different various operations that has been performed by the stack, and one of the applications is a function call. So participants, if you have any queries, please.
Thank you so much, Shubha ma'am.
Yeah, thank you, Ati ma'am. So,
Professors, if you have any doubts, you can ask Subhashree ma'am. I hope they don't have any doubts, ma'am. Thank you so much for sharing your valuable time with us.
yeah, thank you, Ati ma'am. Thank you. Thank you for the opportunity.
As soon as you can leave for the session and you can join by 10:45 for the next session. Thank you.